Alright, warm up here. Take about 2, 3, 4 minutes. Get these 5 problems done. Little review from what we've done this last chapter and the last couple chapters, preparing you for that review test that will be going on Friday. So take a couple minutes to get these 5 done. Alright, now let's walk through these here. So number 1, given the slope and the point. So when I know a slope and I know a point, I want to start off putting it in point slope form. So y plus 1 equals negative 2. Parentheses x minus 3. From there, change it to slope-intercept form. I need to distribute and then subtract the 1 over, and I would get y equals negative 2x plus 5. Alright, so number 2 here. Hopefully you saw this right away, and right as soon as we see that, we always want to distribute, giving us 3x plus 6. On the right side, combine like terms. 4x minus x gets me 3x plus 6. From here, combine the x's, subtract 3x on both sides. Eliminate, that's okay to eliminate. I'm left with 6 equals 6, which would be an example of all solutions. And number 3, simplifying radicals. We're always going to find the perfect square. 27, square root of 27 break down as 3 square root of 3. Square root of 75 would break down to 5 square root of 3. Now I can combine them. 3 plus 5 gets me 8, and still square root of 3. Number 4, simplify. First part here, looking at the numerator. I need to distribute the exponent to my exponents, giving me x to the third, y to the negative 6th, over x to the negative third, y. From here, I just need to move negative exponents. I move the negative 3 to the numerator, move the negative 6 to the denominator. I'm going to be left with x to the 6th over y to the 7th. And the last one, number 5. Find the perimeter of a square that has an area of 225 square units. So the area is 225, which means each side length would now be 15. 15 times 4. I get a perimeter of 60 units. So again, a pretty good review of what you can probably expect to see on the review test coming Friday. Today, though, we are going to start Chapter 3, Section 3.1 here, using graphs to solve linear systems. So we'll be doing a lot of review here of working with graphs, and then hopefully this should be a review of Algebra 1 here with linear systems. Essentially what that is we're going to solve for x and y now on the coordinate plane here. So vocabulary, system of equations, again looking at x and y here. A system of equations is a set of 2 or more equations that have 2 or more variables. So again, mostly we'll be talking about the x and y. A linear system is a system of equations containing only linear equations, so now we're only talking specifically about lines and kind of where they would intersect. A consistent system, a system of equations or inequalities that has at least one solution, so kind of a key there, at least one. And these are the 3 we're going to be classifying towards the end. But an inconsistent system is a system of equations or inequalities that has no solution, so key there, inconsistent, no solution. They would be parallel, as you see over here. An independent system is a system of equations that has exactly one solution, so one solution. And then a dependent system is a system of equations that has infinitely many solutions. Really, a dependent system would be it is the exact same line. So you have one line, the other line would fall right on top of it. That's what gets you the infinitely many solutions. Alright, so the linear systems. A linear system of equations is a set of 2 or more linear equations. To solve a linear system, find all of the ordered pairs that make both equations true. We're not going to be using a table today, so we're not going to focus on that table. We're going to be focusing more on the graphing part here, which is one of 3 ways to really solve these systems. And we'll focus on the other 2 tomorrow. Okay, but in order to graph, essentially, you want to always put it into y equals, or what would be slope-intercept form, y equals mx plus b form. Again, that is the most popular way to graph, and that's the easiest way to graph for us. And then we'll talk about it again later, but to classify the systems, again, you want to write it in that slope-intercept form. Then from there you compare the slopes and the y-intercepts, and then we classify it based on that right there. So number one, I want to graph the equations and find the intersections. So I'm given two equations, and I'm going to use what would be my red line here, and I'm going to use what would be called my blue line, just kind of distinguish between the two. But step one, I want to graph both of them. Now using a straight edge does help, but so number one here, my red line, I'm going to graph it. I have a y-intercept of 1, so I'm going to start up here at 1, if I can get there. There we go, y-intercept of 1. Now with that, I'm going to have a slope of 1 over 1, so I'm going to go up 1 over 1, up 1 over 1, up 1 over 1. And that would be my red line there. And I can connect my dots. So I have my red line. Next, now I have my blue line. Blue line has a y-intercept of 1 and a slope of negative 1. So now I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. Make my dots on my lines. Connect the dots here for my line. And then from here, well, the second part just says, hey, look for that intersection. So I'm right here, looking for that intersection. Where do the two lines cross? If you look right here, they are intersecting at the coordinate 0, 1. That would be our answer. Now the key to these is recognizing we are talking about coordinates because we are talking about an XY answer. So all of our answers need to have the parentheses around them. So there we go. There's number one. Number two, graph the equations and find the intersection. Same thing here. The only problem is this one is not given to us in slope-intercept form. And I always want to have it in slope-intercept form. So if I look at number one, I need to solve for y, get y alone. So in order to get y alone, I need to move the 2x to the other side. So I'm going to add 2x over, giving me y equals 2x plus 3. Now I'm going to do the same thing on the second equation. I need to get y alone, so I'm going to add x to the other side, giving me y equals x plus 2. And then from here I'm going to have my two equations. I'll have my red line, I will have my blue line, just to distinguish between the two. And I'm going to start off with my y-intercept. So my y-intercept is a positive 3, so I'm going to go straight up 3 right there. My slope is 2 over 1, so I'm going to go up 2 over 1. Run out of room. I could also go down 2, left 1, down 2, left 1, down 2, left 1. And I get a line that looks something like this here. And I'm going to do the same thing now with my blue line. So my second line, I have a y-intercept of 2 this time, and a slope of 1. Well, up 1 over 1, up 1 over 1. Looks like my line's getting away, so I'm also going to go down 1, left 1. And now I can see where my intersection is. So if I look at my graph, my intersection seems to be right there with the coordinate -1, 1, which would then be my answer. And again, note my answer has parentheses because I am talking about coordinate. Big deal with those parentheses. Recognize that. Alright, number 3 here. Take a couple seconds, try this one on your own. Graph it. Again, look for the y-intercept. Look for the slope. Notice on the second one, what would your y-intercept be right there? Okay, there is no number, so think about that. But graph these. Take a couple seconds, graph these, then I'll go through the answers. Alright, hopefully you're done graphing these. As I go through here again, I'm going to have my red line, I'm going to have my blue line. So the first one, I got a y-intercept of -4, so I'm going to start right down here at -4. My slope is a -3. Now technically we always want to go down 3 left 1. No more room on my grid here, so I'm going to go up 3 left 1, which still is that negative slope going down. So up 3 over 1, up 3 over 1. Again, recognize negative slope. Good review, know this. Negative slope means it's going down. So as we look left to right, it's going down. Second one here, y equals x. So hopefully you notice this. The y equals x is the same thing as y equals x plus 0. So my y-intercept's right here is 0. X, so I'm going to go up 1 over 1, up 1 over 1. Kind of make my line here. And draw my line right on through. Now I'm looking for my intersection. My intersection is located right here, which would be -1, negative 1. If you want to, think about it, you can always go plug these answers right back in and check. You know, negative 1 equals negative 1. Alright, next one's here. Number 4, same idea here. Take a couple seconds, try this one on your own. Solve for y, get y alone. So on both of them, make sure you understand how to get y alone. Take a couple seconds to try this out. So hopefully it took a couple seconds there. Work these out. These are what your two equations should be. You have your red line, blue line. It is nice having these little colored features on this app. Here I'm going to graph the red line. So y-intercept negative 2. From there I'm going to go up 3 over 2, up 3 over 2. Make my line through. Ooh, that's a really bad line. I'll redo that one. So make my line through. Now I'm going to do my blue line. Slope of y-intercept of positive 3. Again, recognize slope of negative, so I'm going to go down 1 over 1, down 1 over 1. Recognize that negative slope. Some of you kind of missed that on the test, forgetting that negative slopes meant it was going down. From there, once they are plotted, I'm going to look for my intersection. Intersection is located right there at the point 2, 1. And there would be our answer. So again, all of our answers today are going to be intersection points, looking for coordinate answers. So hopefully you got a pretty good review of this. Again, should look a review of Algebra 1, graphing review what we did last chapter. Basically what you're doing is just going to graph two lines and find out where they intersect. Last thing we're going to talk about today is classifying some systems. So we have what is called exactly one solution, or it would be an independent solution, infinitely many or dependent, and then no solution or inconsistent. Now, depending on what book you use and some different things, they'll call it different parts. So just kind of understand there are two technical ways you can call these. Both of them would be acceptable answers. Think of the book, they're talking about inconsistent, dependent, independent is what they'll do. But really what we're looking for here is the lines have different slopes. So one solution, anything that has a different slope. So if you look here, I have the equations. If I can find them here. My equations have different slopes, so they're always going to have one intersection point. So anything with a different slope will always be one solution or independent. Okay, now a little review actually. Those would be perpendicular lines because they are the negative reciprocal slopes. Hopefully you did recognize that. But number 2, or so the second example here is the dependent solution. Again, dependent solution means it's the exact same line. So if I kind of cover this up with a line, still not the best one. There we go, that's not bad. So if I cover up that line, my second line would literally go just right on top of it. It is the exact same thing. And if you look at it, when you put it into slope-intercept form, you get the exact same thing. Y equals 2x plus 1, y equals 2x plus 1. It's the exact same thing. And that means it's going to fall right on top of each other. It's dependent. And then the last one is inconsistent. And again, little review of really what we talked about last chapter, but it's this whole parallel lines. So inconsistent would be the parallel lines. So you're looking at it, it has the same slope, but they have a different y-intercept here. So they would be parallel lines, again, never intersecting, so they're inconsistent. You're never going to get an intersection point. Again, so a little bit of tips here, classifying without graphing. In order to classify them, independent and dependent, inconsistent, those are kind of the three phrases we'll use here. We always want to rewrite it in slope-intercept form. From there, we locate the slope and the y-intercepts. Compare the slopes. If they're different, boom, right away, independent. No need to even go to step 4. Okay, if slopes are ever different, they'll always be independent. If the slopes are the same, then we kind of look at those y-intercepts. If it's the same, it'll be dependent. If it's different, it's going to be inconsistent. So let's look at the next ones here. Number 5 here. So I'm going to classify these without graphing. So if you notice, the first thing we need to do is always put it into slope-intercept form. Y equals mx plus b. Again, one of the first things we always want to do is put in that. So the first one here, I need to subtract 3x, giving me y equals negative 3x plus 5. Second one here, a lot more work on the second one. I need to subtract 15x to both sides, giving me 5y equals negative 15x plus 2. Divide by 5. And I get y equals negative 3x plus 2 over 5. So kind of run out of room here, but I have my two lines. Y equals negative 3x plus 5, and y equals negative 3x plus 2 over 5. So first thing I'm going to do is I'm going to look at the slopes. The slopes are the same, so now it has to be either dependent or inconsistent. Now I look at my y-intercepts. My y-intercepts are different, which would lead me to say that this one is an inconsistent solution because they would be parallel. But that'd be inconsistent because they're parallel. Alright, so number 6 here, I'm going to erase here so I can get some more room. First one's already solved for. Great. Second one I need to solve for y. So I'm going to add 4x over. Giving me 2y equals 4x plus 6. Divide everything by 2. Giving me y equals 2x plus 3. So if you look, I have the equation y equals 2x plus 3. My first equation was y equals 2x plus 3. My slopes are the same. My y-intercepts are the same. This would be, hopefully you're all thinking it, this would be a dependent solution because it is the exact same thing. And then number 7, x minus y equals 5. Again, I need to solve for y. So I'm going to subtract x on both sides. Giving me negative y, don't forget that negative. Negative y equals negative x plus 5. Divide by negative 1. And I get y equals x minus 5. Second equation here, I need to subtract 3. Giving me y equals 2x minus 3. From here I have my two equations. Look at my slopes. My slopes are different. I have a slope of 1, have a slope of 2. Slopes are different. No need to look at the y-intercepts. This would be an independent solution. Alright, independent solution there. So again, looking at the back of these, recognize the different slopes, the different intercepts, what type of solutions they would get. I'll go back a page. But again, these steps will really help you with classifying, going through all that. So again, know these steps. Use those steps on your assignment today if you need to. And then here's your assignment. This is a Blackboard assignment. Do take note. So please get this done on Blackboard. I think it's called like 3.1 on Blackboard. Underneath Chapter 3 now. Recognize that, Chapter 3. And being the nice guy I am, and I am away today, I will give you the 3-point assignment. So make sure you have that done for Thursday, please. All right, thank you today.